Hi, my name is Srinivas Vinakota, and I'm a principal product engineer and a QA lead working on ArcGIS Pro. Along with me today is Charles McLeod, who is the SDK lead for ArcGIS Pro. And together we are going to present ArcGIS Pro SDK for .NET, regression testing your ArcGIS Pro add-in. In this presentation, I'll give an overview of MVVM and testing patterns, how to author tests against ArcGIS Pro add-in, and finally a demo on how to author tests using Visual Studio and Microsoft's MS Test framework. Now let's get started with our first section for a brief overview on MVVM and testing. Model view view model is a pattern that separates the view, which is the UI, from the code, which is the view model that drives the UI. The view binds itself to the view model, and the view model updates the view via notifications. A model is a class that encapsulates the data, and any changes to the data triggers notifications between the view model and the model. This separation of view and view model allows for maintainable code and also helps us in testing the application. Tests can be broadly classified into four categories: unit tests, integration tests, UI tests, and manual tests. Unit tests test one function at a time. These tests are self-contained and do not interact with the data on the file system, access network resources, or any databases. The test passes mock or stub objects to simulate any data required by the method under test. Unlike unit tests, integration tests, on the other hand, interact with the data on the file system, access network resources, or any databases. These are fragile compared to unit tests because of these interactions. On the other hand, these are testing real data as opposed to stubbed out data. UI tests, on the other hand, are automated tests that launch the application under test and interact with the application. Just like integration tests, these tests deal with real data sets and simulate how a user would interact with the application. These tests take longer to execute and are also fragile compared to unit and integration tests. Manual and ad hoc tests are non-automated tests and involve someone launching the application under test and testing the functionality, either following a script or via exploratory testing. When we talk about MVVM tests, we are talking about automated tests that are testing the view models and the classes that contain the business logic. These tests do not test the view or how it binds to the view model. Apart from testing any changes in your code, these tests can also be used to guard against any changes that might arise, say when Pro SDK, .NET Framework, or any third-party libraries used in your add-in project are updated. Because these are non-interactive tests, the method under test or any method that gets called from the method under test should not expect any user interactions, including bringing up any dialogues. These tests could be either unit tests or integration tests. In order to be able to author unit tests against ArcGIS Pro add-in, you must use third-party mock frameworks that allow you to mock static and sealed classes. In this second section, I'll talk about how to get started with creating a test project, preparing test data, and the test lifecycle methods. To get started with authoring MVVM tests, it is recommended that you create a test project in the same Visual Studio solution as the Pro add-in project. Configure your add-in assembly so that the test assembly has access to the add-in assembly's internal members. Next step is to add references to ArcGIS Pro assemblies and any other additional assemblies that were added in the add-in project. Also add a reference to ArcGIS Pro.exe and finally reference the add-in project. When referencing ArcGIS Pro assemblies, set the copy local property on these references to false. Test projects will need to configure a .run settings file. This file contains settings that help the test runner resolve row binaries at runtime. Additionally, we could also set default properties like timeout, platform architecture, and deployment settings. ArcGIS Pro must be license to use on the machine that executes the tests. If using named user licensing, then the work offline option must be enabled to check out a license. This is not required when using a single or concurrent use license. Finally, we need to prepare test projects and test data. It is important to know who the target audience of your add-in is. If your users are outside of your region, then please consider internationalization and localization testing. Because you as a developer might also be the one coming up with test cases, make sure that you do not tightly fit the test data based on your code. For example, if in your code you are expecting a feature layer, don't just test with the feature layer in your map. Also add in other layer types so that you can catch any bugs or regressions. When reusing test data and projects across multiple tests, make sure you have metadata set. This will help you in the long run when someone edits the test data and you have to figure out why the tests fail. Always test for extreme boundary conditions, including testing any exceptions that your method throws. Exceptions can be tested by configuring a test method level attribute and asserting that the method under test does throw the expected exception. Finally, always test your test to make sure it is doing the right thing. This can be accomplished by making sure your test fails during development, and then as you tweak the code or the data, the test should pass. The test lifecycle defines a particular order in which methods tagged with some special attributes are executed. Before any test in any test class in the assembly is executed, a method that has assembly initialized attribute gets called. The first method to execute in a test class is a method that is tagged with class initialized attribute. Before every test that is run, a method in the test class that is tagged with test initialized attribute gets called. Next, the test itself is executed. There are two types of tests: a regular test that is only run once, and second, a parameterized test. In the case of parameterized test, the same test method is executed multiple times, each time with a different set of inputs defined by the test author. Just like we have method initialize attributes, there are also method cleanup attributes. These go in the reverse order as initialize attributes. That is, after a test is run, the method with the test cleanup attribute is called. After all the tests in a test class are run, the method with class cleanup attribute is called. After all the tests in the test assembly are run, the method with the assembly cleanup attribute is called. Now that we know about the test lifecycle attributes, how does testing ArcGIS Pro add-in fit in here? Since we only need one instance of ArcGIS Pro application per test, we initialize and start up Pro in assembly initialize and shut it down in assembly cleanup. In the class initialize method, we can open or create Pro project, database connections, etc. And conversely, in class cleanup, we close Pro project and database connections. This is useful if all the tests in a given test class use the same project. If this is not the case, then opening and closing projects should be done inside the test method itself. In the test initialize, we can set any properties or state that is common to all the test methods in the test class. And conversely, we reset these values in the test cleanup method. Again, this is useful only if all the tests in a given test class have a need for these properties or state. If not, it is best to set these values inside the test method itself. In this final section of this presentation, I'll demonstrate using Visual Studio how to set up a test project, modify the add-in so that it is testable, create test data using ArcGIS Pro, and finally, how we could find bugs, fix them, and retest using our regression tests. Now for some technical details on the operating system and software version used in this demo. I'm using ArcGIS Pro and ArcGIS Pro SDK for .NET version 2.7. For the add-in, I choose the Get Symbol Swatch project in the map authoring folder from the GitHub ArcGIS Pro SDK Community Samples repo. I'm using Visual Studio Enterprise 2019 version 16.8.2 and MS Test Framework version 2.1.1. Finally, these tests are run on Windows 10 build 1809. Here I am at the Get Symbol Swatch add-in sample in ArcGIS Pro SDK Community Samples repo in Esri's org on GitHub. This add-in shows how to create swatches for different types of symbology for use in WPF. It loops through every feature layer in the map and builds a list of symbol swatches, including the feature layer name, renderer type, label, and the symbol itself. Using Visual Studio, I built the add-in. Now I'm ready to test this using ArcGIS Pro. As a first step, I'm going to do some ad hoc testing to make sure the add-in works as expected. Later, I'll create a MS test project to automate my testing and to catch any regressions as I work with the code. Using ArcGIS Pro, I added few feature layers and a raster layer. Now remember, my code deals specifically with feature layer types. And knowing this, I could as well just add feature layers in my map. But the point here is, as I refactor my code, I want to be able to catch any regressions. So I switch over to the Symbol Swatch tab, bring up the Symbol Swatch dock pane, and click on the refresh button to populate the data grid. And let's see what happens. Well, the application doesn't crash when we want it to crash. So let's retry it again. Click on the refresh button. There we go. Before I was recording, this crashed on the first click. Now, to figure out why the application crashed, let's start uh, debugging this code and see what happens. So bringing up the Symbol Swatch dock pane again and clicking on the refresh button. There we go. The code was expecting to loop through individual groups set on the unique value renderer, but in this case there were no groups, and that's why it crashed. Now, one thing we could do here is we could fix this issue right here and then retest the add-in. In this case, we have a very simple add-in. Now imagine if this were a complex add-in and we need to repeat a number of steps to reprove the crash. It becomes quite cumbersome to test and fix issues. An alternative is to author regression tests, which would make our dev life much easier. To get started with testing, let's first create a unit test project. I right-click in the solution and click Add a new project. I'm going to choose a unit test project type and click Next. Here I'm going to name my unit test project Get Symbol Swatch Tests. The first thing I want to be able to do is to create a run settings file. I have a pre-created run settings file that looks something like this. In this file, I configure a default test timeout of 90 seconds, giving all the tests in my test assembly 900 seconds to execute. I also set the directory path where ArcGIS Pro is installed. This helps the test runner to resolve pro binaries at runtime. Now, as a first step, I need the test project to access internal members of my add-in. So I go to the assemblyinfo.cs and I add allow access internals visible to. Internals visible to, and I give in my test project name. The next step is to add references to our get symbol swatch tests project. To do so, make a list of all the ArcGIS Pro assemblies that are referenced in the add-in project. Next, go over to the test project, right-click references, add references, and add all the ArcGIS Pro assemblies. ArcGIS Pro.exe is something that you wouldn't reference in your add-in, but this is required in the test project so that we can launch the application, initialize ArcGIS Pro. Now the next step is to set copy local to false on all these ArcGIS Pro assemblies. An easy way would be to select all the ArcGIS Pro assemblies, right-click Properties and set Copy Local to False. In the next step, I'm going to add a class called testenvironment.cs, which will hold a couple of let me add that class testenvironment.cs. This class holds a couple of methods called assembly initialize and assembly cleanup. This is where I'm going to be starting the application and stopping the application. So here I have my get symbol swatches test environment class ready. In this, I declared an assembly initialize and an assembly cleanup. The assembly initialize method will be the first method that gets called whenever tests are run. In here, I'm going to start the application, which would initialize an instance of Pro app and also call this method test mode initialize assembly. And when all the tests are run, the assembly cleanup method would be called, which would in turn call the stop application method. The stop application method shuts down the application. Now switching back to our unit test class, the first thing I'd like to do is rename this class into something meaningful. I'm going to call this class symbol swatch docpane view model tests. The next step, I'm going to delete the existing test method template and I'm going to add a class initialize, a class cleanup, a test initialize, and a test cleanup methods. In the class initialize method, I'm going to open my test project and I'm going to loop through all the map items in the project and pick a map that's called map. And from this map, I'm going to get a list of all the layers. Now, because as a test author, I know I'm only going to be working with one single project for all the tests in this test class. It makes sense for me to open the test project in class initialize. If this were not the case, then I'll have to open a different project within the test method itself. So as a first step in getting started, I'm going to add a test method, and I'm going to call this one swatch count test. I'm going to change this to be an async and return a task. Now I need to access my view model. It should be show. Oh wait, I never added a reference to the add-in itself. My bad. Let me change this back to void, build my add-in, and make sure everything works as expected. Let me add using get symbol swatch, and here now let me create an instance of my symbol swatch top pane view model. Now, the reason Visual Studio throws this error is because my dock pane view model is not accessible to anyone outside of this assembly. I'm going to fix that here by adding the internal access modifier. Now, in order to build the list of symbol swatch infos, the view model is currently set such that I need to execute this command refresh swatches. So let me go ahead and get an instance of the command. And I'm going to call the execute method on here. And just to be sure my test is working fine, I'm going to add an assert statement with a ridiculous value of 99. Like I'm expecting that this method, when I execute the command, the symbol swatch list would contain like 99 items in it, which I know is not true. Go to my list and count, and I'm going to assert that symbol swatch list does not contain expected number of swatches. So let's go ahead and execute this test. Now, the first part I'm interested here is the test should crash, because that's what happened when we were testing in the ArcGIS Pro application. Our test failed, and let's see if it gives us a good reason. Let me go ahead and dock this at the bottom of the screen so that it's easier to read the full message. So as expected, our test failed because we are expecting 99 and what we got was 0 symbol swatches. But if you recall in the application, we saw something like 3 symbol swatches being generated. When I click on refresh and before the application crashes, if you notice we have 3 symbol swatches, and that's what we expect our test to return, not 0. So there is something else that's going on which is not right. So let's start debugging in here. I'm going to set a breakpoint in my command and start debugging the test. So here we are. As I step into the code, I do not have an active map set. So let's fix that in our test. I could get an active map by opening a map view. Now let's rerun our tests and see if it shows we have 3 items in our list. It still doesn't contain the number of swatches as we expected. So now let's go ahead and debug this code further to see why the symbol swatch info list has 0 items in it, while we are expecting 3 items to be in there. Debugging my test again. So our test fails here. Hey, look what happened. It entered our lambda after the assertion hit. So there is something else going on here where our test gets the swatch info list count after it exits the test method, or just as it is about to exit the test method. So clearly there is something wrong in our code. Let's re-examine our code and see what's going on. So our command executes a task. Ideally, I should be able to await until my task is done. And the reason I can't await on this is because this property does not return an async in the task. So one way I could fix this is to explicitly call wait in here. But this defeats the whole purpose, where the UI might be stuck waiting for this part of the code to execute. And this is not a recommended change. Later, I'll show you how we could have a better fix. But let's see if our test works as expected at this point. Okay, now it failed. Oh, but now it failed with a different kind of error. It's a null reference exception. And let's see where this one is crashing now. How? It's the same issue that we found uh, as earlier when we were debugging our add-in following the probe crash. So I now I could fix this crash here while I'm running my test, and then let's see if let's see what happens next. So I'm going to add a check if unique value renderer dot groups is null, then I'm going to continue. And then I'm going to rerun my test. At this point, I'm still expecting a uh, ridiculous value of items in my swatch info list, which I know is not true. I'm expecting it to show like 3 items in there. Now the assert message says expected 99 items, but it found only 3. So now I know that my test is doing the right thing. I'll go ahead and update this value to 3. Rerun my test and make sure it passes. Okay, now getting back to our code, uh, the fix that we did previously to add a weight in our add-in uh, in the view model, is incorrect. This defeats the whole purpose of keeping the uh, application active. So let me go ahead and undo this change. And instead, I'm going to add a new method called update collection, which would accept an enumerable of layer, and I'm going to move all my uh, code into that method. Next, I'm going to call this method from within my uh, command. And to this, I'm going to pass in the list of layers. Now, I'm going to ignore this warning here because I don't want the code to wait when somebody hits the uh, refresh button in the add-in. But now, because I'm returning a task, this means I can now await if I'm calling this update collection function. So to take advantage of this refactor, I'm going to modify my test and not call the command. Instead, I'm going to call the update collection method that I just created. Update collection, and I'm going to pass in the layers list I have. Now let's rerun this test and make sure it works as expected. Ah, so we have a different kind of error. After I refactored the code, I get this invalid cast exception. It says unable to cast object of type group layer to a feature layer. Let's go back to our view model and see what happened. So previously, the add-in was capturing a list of feature layers and passing it to the update collection method. But in our test, we are capturing a list of all the layers in the map and passing it to the update collection method. And this includes the group layer and a raster layer that I added in my test project. So here I have a couple of ways to fix this issue. I could either accept a enumerable of feature layer types and then go ahead and fix my code. Now let's try running the test again. and our test passes and our refactor is successful. So moving ahead, I'm going to show another test type called a data-driven test type or a parameterized test type. To do this, I'm going to copy some code in here. Let me fix this. So what this is a parameterized test or a data-driven test. One noticeable difference is the a simple test method which executes just one test case has a test method attribute, while a parameterized test or data tests have a data test method attribute. There are multiple ways you could specify the input parameters. You could use these test cases could be coming from an external CSV file, Excel file, or from a database, or you could also list them as here. Now, these values are passed to the test method as the function parameters. So here what I do is I create an instance of the document view model. I call my update collection method where I'm restricting the layer that I'm passing into this collection based on the layer name that I have in my test case. And then for each of these test cases, I can assert that it returns the right uh, feature layer name, renderer type, and also the label. So let's see what happened here. The class breaks renderer test. The second one failed. So let's debug our test and see why this one fails. Ah, that's because we are expecting an empty label in here, but in fact it returns a value. Let's confirm in the application that this is the expected result. So our second class break does have the value. So I'm going to copy that value and I will replace it in my expected value list. And I'm going to rerun my test. And my test passes. So as a final confirmation, I'd like to run all the tests in my test class to make sure that everything works together. All right, now, now that all my tests are passing, I feel confident that I could go ahead and make updates to my view model and not have to repeatedly bring up ArcGIS Pro application to test my changes. I could run my regression tests and confirm that my changes are good. This concludes my presentation. Please provide your feedback for this session by clicking on the session survey link directly below this video. The slides and the code demoed in this presentation can be found at the location shown in this slide, or use the QR code to get to the GitHub repo hosting the material. Thank you for watching.
Okay, well, thanks for your attendance at the session. This is the live Q&A. Please put questions into the Slido. Some of you have already. We'll either type answers there or we can actually answer verbally. I think you guys can hear us. Okay, so there is a question. I'll just move it over. Is it possible to do the same things with the NuGet package? I assume Giacomo means, is it possible to do the same things with regards to testing using the NuGet package? And yeah, I don't see why not. Srini, there's a question there. How would I publish test data on a build server? Is it also part of our VCS the same way that tests are? Srini, is that one that you'd like to answer?
So if I'm reading the question correctly, I'm assuming they meant how would the build server access the test data? So in our particular case, we have all the test data available on a network drive. That's how we access our test data sets.
Yeah, it's a good question.
And during the live session, we have had a couple of questions come in. Is it possible to use a different test framework other than the MS test framework that I demoed? Yes, it is definitely possible to use any test framework as long as it supports authoring tests in C# or VB.NET if that's what you're using. We have a poll going on right now. So after you attended this session, how likely is it that you're going to author regression tests while developing against ArcGIS Pro SDK? Please take a moment uh, to to answer the poll.
Okay, there's a question from Marcel. That's a really good question. It reads, I've lost it. Yeah, the test mode initialize async method. Right, so test mode initialize async, it's in arcgis.desktop.internal.core. So it's in an internal namespace, meaning it's not part of the public API. So it is not for use in add-ins, though you can use it in your tests. It initializes a headless version of the Pro application. So basically, it's most of the Pro app with the exception of the Beagle viewer, and it is there essentially to allow you to write your regression tests. If you download the code sample, you'll see that there's a using statement in Srini's little test environment class that adds that desktop.internal.core namespace. And actually, that's a segue into a previous question we had during the session about instantiating the application if you're writing a unit test for a configuration. There's a flavor of the Pro app constructor that actually takes the name of the Pro config X. And so you'd instantiate the Pro app in your unit test with the name of the configuration if you were loading Pro under a configuration for your test purposes.
Okay, Justin has a question. Are there limitations in testing capabilities in different versions of ArcGIS Pro? No, there are no limitations. Uh, in fact, you could use the same concepts that we showed today, going back to any version of Pro starting at 1.0.
Srini, there's a question on particular test automation flavors. I think that's right up your alley. I'll move that over on SpecFlow or Gherkin.
That's a good question. I recall one team trying out SpecFlow, but it never really panned out because the team was spending too much time defining that spec, and they figured it's rather easy for them to just straight up write the tests. But again, the result might be different in your case. It depends on your workflows.
And then anonymous question about the project template. I think let's move that one over. I think the questioner is asking about the Visual Studio project template that you used to create the test project as part of your overall solution.
I've used Visual Studio 2019 and ArcGIS Pro version 2.7. My project consisted of a single map with a couple of feature layers and a group layer and a raster layer. I just threw in some different layer types.
I think he's asking more like when you go right-click new and you say add new project, there's a particular project template type that gives you a test project. I think that's really what he's asking. Okay. So if you were professional, for example, Visual Studio 2019 professional, if that comes with professional, do you need the enterprise flavor and so on and so forth?
No, you wouldn't need the enterprise flavor to author tests. A professional would do good. You only need enterprise if you plan on writing tests using mock objects or using Visual Studio fakes. That's the only time you'll need Visual Studio Enterprise.
Okay, question here about the use of QTask. I'm not aware of that. The questioner asks, was the use of queued worker? Well, okay, sorry, I misunderstood the question. I see the use of QTask.run instead of queued worker.run. I believe in earlier versions of Pro, QTask.run could not be called from a unit test. In what Pro version did QTask.run become callable in a unit test? Okay, so there are two parts to that question. First, QTask versus queued worker. Queued worker is to give you a single threaded apartment semantic, similar to queued task in a standalone core host application. It's not really there for use in unit tests. With regards to could QTask.run not be called from a unit test in earlier versions of Pro? I'm not aware of that. I think it's, as far as I know, Srini, correct me if I'm wrong, but I think it's always been usable since 2.0 at least in a unit test.
Yeah, as far as I know, I've always used QTask.run, and I do not recall about queued worker before.
Yeah, that's a special. It's a part of a different namespace, and it's used in what are called core host apps.
Okay.
So it's something different. Is there a link to the documentation on the steps that you followed if someone wants to follow along with what you did?
I replied in the chat to that question. I pasted a link to our GitHub repo where we have the sample.
Great. I think if there, we could also create what we call a pro guide, which is where we sort of do a step-by-step on how to actually create a test project, sort of in the fashion of a tutorial. I think this is a good candidate for that. So we could take Srini's sample and actually make a pro guide that we add to our Pro SDK wiki. So I think we could definitely make something like that for this. Okay, another question off topic. I would like to create business logic in .NET Standard written against either Pro or Runtime SDKs. Can I share business logic assemblies that use Esri objects between the two SDKs and consume in the other? No, they're two separate SDKs, so they're not compatible with each other.
Charlie, we have 3 users who responded that having a pro guide to author tests is an awesome idea.
Okay, so let's do that, Srini. Let's
Yes.
collaborate on that and make that happen.
Sure.
So
Yes.
yeah, we'll definitely do that. Testing. Okay. Yes. Yep. Okay. Yep. Thank you for the feedback on that.
So we have about,
sorry. Go ahead.
sorry, so we have about a minute left. Are there any more questions?
I just want to mention that we are working the showcase Ask Our Experts area. So if there are additional questions you have from the session, you can get a hold of both Srini and myself in the Ask Our Experts area for Pro. Go ahead, Srini.
So we have one last question. Can you test the changing of layout views during the execution of a task? Yes, you can. uh, the way you switch or you activate, like you would need to activate a layout from the test, and then you can pick some property of the layout, either the layout name or if you are expecting certain elements to be on the layout, you could pick those and validate that the switch did happen.
So Srini, just one quick thing, very interesting on the second poll you put out, which was how likely you're going to author regression tests. So after the session, it's 63% is very likely.